There are a number of fertilizer issues around the world that concern the industry. Particularly, we are concerned with the impacts of nutrients on water quality. When we sell our nutrients to farmers for their use in growing crops, we want to ensure that those nutrients are used efficiently by the crop and that they stay on the field and have a low potential for movement to both surface and groundwaters. Hypoxia is a low oxygen condition that occurs off the coast of Louisiana in the northern Gulf of Mexico each summer. It's a natural condition, but there is a concern that nutrient enrichment from the Mississippi River is causing the condition to worsen. Hypoxia is a condition where the oxygen level in the water is less than 2 milligrams per liter. That condition makes it difficult for fish that can't readily swim out of the area to be very productive. There is a concern among the fisheries in the Gulf of Mexico that it's getting more and more difficult for them to catch fish because of the hypoxic condition. However, to date, the science indicates there has been no economic damage from hypoxia on the Gulf fisheries resources. There are a number of factors that contribute to hypoxia development. First is a source of nutrients. Those nutrients that are coming down the Mississippi River of concern are primarily nitrogen and phosphorus. The greatest concern has been the nitrate nitrogen discharge. That fuels the development of microscopic organisms called phytoplankton. They're like algae. In addition to the effects of the nutrients in the water, there is also the issue of fishing intensity, perhaps catching more fish than is safe for the Gulf to maintain its sustainability. We are also concerned about other pollutants that may impair the natural function of the Gulf. Some have suggested that perhaps we're using fertilizer sources that are too water soluble and that we should use organic nutrients instead that have slow release characteristics. However, we can manage fertilizer sources of nitrogen much more effectively because we understand their release characteristics. We can apply them uniformly and very accurately with our equipment and technology that we have at hand. Organic sources, such as animal waste, are very difficult to predict in their behavior. We cannot control their nitrogen release rates, and when we apply them, we typically have to apply them several months or weeks before the crop is planted, which means they're subject to the fate of the environmental conditions at the time before the plants have the opportunity to absorb them through the roots. The media has been more concerned with the hype related to the hypoxia zone rather than the science. It's regrettable because many of the scientists that have been in charge of monitoring and mapping the extent and the duration of the hypoxic zone have been open to discussions with agricultural scientists on ways that we can work together to remedy the problem. It's unfortunate that much of the media has been fairly lopsided to date. We are using site-specific technologies, and we're doing a better job of understanding the hydrology, particularly next to waterways, such that we want to avoid the use of too heavy rates of fertilizer, principally our nitrate sources and our phosphate sources that may move with water across the surface of the landscape. And so we are delaying application in some of those areas until the crop is fairly well established and has a very effective root absorbing system. The other things we're doing with our site-specific technologies, we're identifying the more productive areas of the field, and we're putting nutrients there where the plants can effectively use them. And we're also identifying areas in the field that are less productive, and we're minimizing the nutrient input there to enhance the nutrient use efficiency. We believe that farmers are becoming better managers. We're seeing greater adoption of the technology tools that are available, and we continue to conduct research with controlled release sources and better management and timing, better hybrids, better varieties. And when all these tools are put together, we really believe we can have a very positive impact on water quality.